and we are off for chapter 3. Like I said, we are skipping chapter 2. And don't worry, just be grateful. Believe me, if we did chapter 2, you'd be like, oh my goodness. Chapter 3, I think, is a lot more, I don't know, say the word normal, but that's what it is. All right, so let's do this. In my notes, I have a definition for transversal. I'm just going to read it to you. I'm not going to have you write it down, but I am going to draw a couple pictures, and I want you to draw those pictures. So people say, how do I take notes in your class? Well, it's very easy. Somebody tell me, how do you take notes in my class? Whatever I write on the screen right here, okay, that's what you write down. So anything I write down here, you should be writing down. That's how you take notes. That's how you stay awake. I watched a video last night, just popped up on I watch a lot of math videos too, so I learn how to teach certain subjects and just to see how other people are teaching it. Anyway, this one popped up, and this girl she was a doctor, a medical doctor, and she had this video about how to study. She said she didn't know how to study, and she had this like 5 things that helped her to study to be a doctor, right? And one of them was what she saw, pre-note taking, which means, now look, for some of you guys, this would blow your mind and you would never even think about doing this. But this is what she did. When she went to college and she wanted to succeed, she did pre-note taking. What does that mean? She didn't wait until you came to class. That's right. She knew what they were going to study, right? They knew they were going to be on chapter 3. So what did she do before she even walked in the first day of class? She did chapter 3. She looked at it. She opened the book or whatever chapter it was, right? And she took notes. She highlighted stuff in the book. She wrote down things that she thought was important. So when she walked in, the very first day the professor lectured on chapter 3, guess what? She already knew a lot of these words, right? She was already kind of familiar with what was going on, all right? It's hard enough for you guys to take notes when I'm telling you and you're right in class, all right? But I'm telling you, that's something that maybe you never even thought of before, right? But it might be a good idea. So when you see for the next week, when it says we're going to do section 3.2 or whatever, all right, it might be a good idea the night before, just look over it. Familiarize yourself with some of the words that are in there, all right? And then when you show up to class, you're like, oh yeah, I've heard that word before, and that really, really helps. It really does. She went on and on for some other things too, but that's something that I thought I got to talk to my kids about that in my classes. Not that anybody's going to do it, but you should. It'd be a good idea. Did I do that when I was in school? No. I should have. Okay, it would have made life a lot easier for me, but that's something to think about. Okay, if you're a serious student and you are serious about getting good grades and learning this stuff, then do some pre-studying, some pre-notes, all right? Put it on in your notebook, pre-notes, right? And then look through the book. I mean, you can read, right? You can go through the book and see what's in there and just write some of the words down. And maybe you didn't understand some of the things, but then that's what we do in class, all right? All right, enough of that. Let's talk about transversals before we even talk about parallel lines, okay? So we're actually going to do quite a bit with transversals before we even mention parallel lines. So a transversal is basically a line. I'm going to do this. I'm going to draw 2 lines right here. Now technically they're not lines just yet. Why aren't they lines? They don't have the arrows. Okay, so there's a line, there's a line. Now there will be times where I'm a little bit lazy and I don't put the arrows on there, but these are lines, okay? What in the world is a transversal? Well, I'm glad you asked, because we are going to draw one. I'll do it in a different color so it pops out a little bit more. Transversal, I'm going to read the definition for you. Might be a little bit wordy, but when I draw the picture, it makes sense. You're like, okay, it's not that big of a deal. Transversal is pretty easy. Okay, it says it's a line that intersects 2 or more coplanar lines in more than one point. Okay, now that was a little wordy, but what does it say? A line that intersects 2 other lines. So draw one. Boom, right there. Does that fit that definition? Yeah, let's read it again. It's a line, that red one, I'll put arrows on the end so you make sure you know it's a line, that intersects what? 2 or more lines, okay, 2 or more, I got 2 right here. Does that red line intersect those 2 white lines? Yes, they do, okay, in more than one point, which means it intersects this line at this point, intersects at this point. So what is that red line called? A transversal. Good. Transversal. You could say transversal line. It's fine. Okay. Most of the time we just shorten it. Just say it's a transversal. Okay. Everybody with me on that? You could have lines going all kinds of different ways. You could have 3 lines. Watch. Copy, paste. Let's push this down a little bit. And then what if I have another line going like this? All right. And then I have a line that crosses all 3 of them. What is that red one right there? It's a transversal because it's a line that intersects 2 or what? More. 2 or more lines. Okay? I didn't put the arrows on there, but you get the idea. What's that? Anything I draw up here, you can draw. Okay? So those are all examples of transversals. Here's one that I didn't talk about. I got it in my notes though. But is that still a transversal, that red one? Yeah, it is. Okay. That white one, now if it was a line, that means what? This would keep on going forever, right? And you could even consider the white one, this one right here, right? The one I highlighted, that one. That could also be a transversal because what does it do? It intersects, it intersects 3 lines, doesn't it? So this could be a transversal as well, right? Because it fits the definition. Everybody good? All right, easy enough. This one right here, yeah, the bottom one would be. You're right, because it would intersect here and here. So you could consider that a transversal as well. We're not really going to see this. We're not going to deal with this, but here's what we're going to do now. Now, this kind of gets away from transversals, but it's something that's important for what we're going to talk about in a few minutes. Okay, what if I have 2 lines like this? Again, they're lines. They could be line segments too. It really doesn't matter. So I'm not going to put the arrows on there. But if you look at it, let's label some of these angles. It's a lot easier labeling with numbers, wouldn't you agree? Instead of like ABC, CDB, and all that kind of stuff, right? So that's angle 1, that's angle 2, it's angle 3, it's angle 4. Does that mean that's one angle is 1 degree and that is 2 degrees? No, it's just the name of the angle, all right? So here's something that's really interesting that you may have never thought about. I'm sure you've never thought about before, but I think it's kind of interesting. Anytime you have 2 lines that intersect, is either one of those considered a transversal? No, because it only hits at one place, right? So they're not transversals, but they are 2 lines or line segments, and they do intersect each other. So if you have 2 intersecting lines, what I'm going to show you right here is always true. They form how many angles? 4 angles, all right? 1, 2, 3, 4. Now, take a look. What do you think might be true about angle 1 and something else? Very good. That's awesome. That's exactly what we're going to say, okay? Angle 1 and angle 3 are absolutely equal to each other. Let me just show you why real quick. I don't usually do this with CP, but you guys look like you're ready to learn this, okay? What's true about angle 1 and 2? We kind of had this on the test. They make the same line, so they add up to what? No. Angle 1, give me an angle degree. I want a degree. Angle 1 and 2 add up to what? 180. Very good. 180. Why 180? Because you told me it was a straight line. Right. It's a straight angle, straight line. So that's 180. Agreed? All right. So tell me something about 2 and 3 now. Angle 2 plus angle 3 also equals what? 180. Now watch this. This is equal to 180. This is equal to 180. So what must be true about this and this? No, we haven't even mentioned parallel before. They're equal to each other. That's right. If this is 180 and this is also 180, then what must be true about these 2 things right here? They got to equal each other. So check this out. Angle 1 plus angle 2 must equal what? Angle, well, we already know that up there. Equal angle 2 plus angle 3. Everybody see that? All right, because they're both equal to the same thing. Yes? Now, check this out. Remember algebra? Whatever I do to one side, I can do to the other side. Let's get rid of this angle 2. How can I get rid of this angle 2? Subtract it. So subtract angle 2. subtract angle 2, because they're the same exact angle, right? So I'm allowed to subtract from both sides. What happens here? Cancels, cancels. Now, check this out. Donnell said it already, but this is why. This is actually a proof. Abdul, you paying attention? I thought you were turning over a new leaf. All right, we weren't going to sleep. We're going to take notes. Okay, you writing any of this down? If you write this down, it's not impossible, but it's much more difficult to fall asleep if you're actually writing it down, okay? Because you're involved, you're doing something, all right? It makes it a lot easier. Now look, believe me, I've been in the middle of correcting homeworks or making up a test or grading a test, and I've fallen asleep right on the kitchen table with my head on the papers, all right? So I've done it myself, but it makes it a lot more difficult to fall asleep. So what's true then? Angle 1 must be what? Equal to angle 3. So we just did a proof, all right? We're not going to really talk about proofs this year, but we just proved that 1 and 3 are equal to each other. We could do the same thing with 2 and 4, but what do you think might be true about 2 and 4? They're going to be equal to each other. That doesn't mean that 1 and 2 are equal, but look at the ones that are across from each other. Do you see it? See how 1 and 3 are like on the opposite sides of each other, if you want to call it that? Do you see how they're opposite each other, and 2 and 4 are opposite each other? So anytime you have two lines that intersect each other, you have two pairs of equal angles, right? 1 and 3, 2 and 4. We give it a special name in geometry. We don't say that they're opposite each other. We call those vertical angles. Okay, I'll just put the angle symbol. So 1 and 3 are vertical angles. 2 and 4 are vertical angles. And so what must be true about vertical angles? What's true about 1 and 3? What's true about 2 and 4? They're equal to each other. So we can say that vertical angles are what? Equal. Now in geometry, a lot of times we use this symbol. What's an equal sign with a little squiggle on top? It's congruence, not an estimation, not with an equals underneath of it. Okay, if it was two squigglies, that would be approximately or estimated, okay? This, with an equal sign with a squiggly on top, that means what? We haven't really talked about that a whole lot. It means congruent, that thing right there. For the most part, I'm okay if you just say things are congruent, for the most part, okay? There are times I'm going to be real picky about saying congruent. That's going to be another chapter. But you can just say that they're equal to each other. Or vertical angles are congruent. Or vertical angles are equal, all right? That comes into play a lot. So look for that stuff. When you have two lines that intersect each other, look to see the angles inside, and they would be congruent, all right? What is it, 9:38? All right, I still got some time. Wednesday just throws me for a loop. All right, now we're getting closer to talk about the parallel stuff. We're not there yet, but we're getting there. We're going to go back to transversals again. All right, I'm going to draw pretty much the same thing that I did earlier. Now look, we haven't talked about parallel, but you've heard that word before. You know what parallel means. What does it mean for two lines to be parallel? The same? It means they're the same? They never touch each other. That's right, okay? If you want to get really technical, because we actually talked about two lines that didn't touch. For instance, let's use this box. Look at this box right here. Look at this. See this line right here? Okay, see this line right here? Are they ever going to touch? Are they parallel? No, this line right here will not touch this line right here. This one keeps going this way. This one's below it, and it keeps going this way. They'll never touch. They'll never intersect each other. But they're not parallel. What do we call them? We did this word before. I think we did. You know, maybe we didn't. Okay, maybe it was the honors class I'm thinking of that we did it in. We call those skew lines. But this line, did we do skew? Yeah, okay, I thought we did. All right, so this line right here and this line right here are skew lines. They're not parallel, but they don't touch. So we can't just say they don't touch. They have to be in the same what? Look, this one and this one are parallel. Do you see it? See this line right here on this box? And this line on this box? They are parallel. Why aren't they skew? Because they lie on the same plane. They lie on the same plane, which means they are coplanar. Coplanar, okay? You got to learn these words. Okay, you've got to learn the words, all right? If you're going to ever learn another language, which I wish I knew, but I don't know another language, you're going to have to learn the vocab words. You got to know what stuff means, all right? If you're going to learn geometry, you got to know what these words mean, all right? So, parallel line, and I kind of got off track. I don't even want to talk about parallel lines just yet. I just kind of got too excited about parallel lines, all right? Now, check this out. I got two lines cut by, and that's the word we use in geometry. If it intersects it, we say these two lines are cut by a what? A transversal. Everybody hear me? So I've got two lines that are cut by a transversal. That's what this picture right here indicates. You okay with that? All right. Now, if you have that situation, now, did I say that those two white lines are parallel? Did not. In a few minutes, we are going to do that. We are going to talk about two lines that are parallel to each other, but not right now. What I'm going to do is I'm going to put some numbers in here for these angles. Now, after doing that vertical angle thing, you could tell. Look, I'm not telling you any degrees for these, am I? I'm not saying this angle is 50 degrees, that angle is 80 degrees. I'm not telling you any of that stuff. Okay, but you could tell me right now 1, 2, 3, 4 pairs of equal angles. Like, see this grouping up here? Tell me which angles are equal to each other up here. 1 and 4 and 2 and 3. That's right. What about this grouping down here? 7 and 6 are equal and 5 and 8 are equal. Why? If I asked you why, what would you tell me? Because they are what? Vertical angles. And vertical angles are always equal to each other, congruent to each other, okay? So, there's 4 things that we know right now just by that, without me giving you any numbers at all, okay? So, we're going to deal with that a little bit. But we have some names. This is just vocab right here, all right? We have some names for some other relationships between these angles, okay? If I compare one angle with another angle, all right? So, let's do the first one. The first word is called corresponding. Write this down because we're going to be using these words a lot. All right, this is like a big part of geometry right here. It's one of the big major lessons, all right, in geometry. So this is called corresponding. Corresponding angles. I'll just put angle apostrophe S. Okay, what I'm doing is I'm just listing the pairs of corresponding angles. What does it mean to be corresponding? It means it matches up with something, all right? Remember I said, let's look at this group up here and this group down here, all right? That's what we're going to do. So let's take a look at angle 1. Angle 1, I'm going to put just a comma. Angle 1 is where in this top group? It's like in the top what? Top left. So let's jump down to here. Which one is in the top left of this group? Okay, so 1 and 5 would be considered what? No, we didn't say equal. We did not say equal. They're corresponding angles. We're just learning the names of them, okay? This is the relationship, okay? How do they relate to each other? They're called corresponding angles, all right? There's 3 other pairs of corresponding angles. 2 and 6, okay, let's write them all out. Now notice, I am not putting equals, am I? Now I will in a few minutes, but not right now. All right. So 2 and 6 match up. Let's go in order. 3 and what else? 7 match up. And what else? 4 and 8. Okay, so everybody sees the corresponding angles. That's probably the easiest one, and that's what we're going to do first. Everybody got that? All right. So now, let's go to a different color. Here's another word. So corresponding angles. So that's how you know. You look at this group, look at this group. That's the top left. That matches up with the top left. That's the bottom left, matches bottom left. Top right, bottom left, or bottom right, bottom right. Everybody got it? Yeah, easy. All right, let's do another one. This one is called alternate interior. I'll write out the word. Interior angles. Okay? Alternate interior angles. So I'm going to show you which ones are alternate interior angles. Alternate means one's on one side, one's on the other side. Interior, let's talk about that word interior first. Interior means inside. Inside what? Inside those two white lines. Give me all the angles that are in between or inside the interior, okay, of those two white lines. 3, 4, 5, and 6, okay? Now, alternate means they're like complete opposites, okay? Everybody hear me on that? They're complete opposites, but they're inside the two white lines. So let's take a look at angle 3. Which one is completely opposite of angle 3 inside the two white lines? Angle 6, that's right. So angle 3 and angle 6 are alternate interior angles. Does that make sense? Okay, interior means they're what? Between the two lines, all right, the two white lines. Alternate means they're complete opposite, all right? That one is completely opposite of this one. You with me? Yeah. All right. What are the other? There's one other pair. What is it, Evan?
4 and 5.
Well, one's not interior, okay? 4 and 5. 4 and 5. I'll put a little box. Look. Because 7's exterior. Look, what are the exterior ones? 1, 2, 7, and 8. What are my interior ones? 3, 4, 5, 6. So the ones that are completely opposite inside the two white lines are 3 and 6 and 4 and 5. So I can add 4 and 5 to the list. There's only two. There's only two pairs of alternate interior angles. Everybody got me? Okay. Oops. Get rid of all of this. All right. Got another one. Very good. I was going to ask if somebody could guess it, and you got it already. All right, so the next one, I'm going to shorten that alternate, since I already wrote out the whole word. Alternate, exterior angles. So you should be able to figure that out if you know what alternate interior angles are. All right. So again, what are just the exterior angles? 1, 2, 7, and 8. So those are the only ones we're dealing with, okay? Forget 3, 4, 5, and 6 because they're not exterior. Which ones are completely opposite? 1 and what else? And 8. That's right. So angle 1 and angle 8 are alternate exterior angles. Everybody with me? All right. And then 2 and 7. Very good. I'll put a box around that. 2 and 7. Okay, so 1 and 8 are alternate exterior angles. 2 and 7 are also alternate exterior angles. Have I said anything about them being equal to each other or anything like that? Nope, haven't said it. All I'm doing is just trying to show you the names of these certain relationships between those angles. You with me? Okay, we'll see. Here's the next one. Yeah, we can fit it in here. Go pink. The next one, I've got two different ways to name it. This book, I don't really like how they name it. I think maybe some other books do, but the first time I taught geometry way back, the book named it the way that I think is the best way to name it. And but this book doesn't use that. This one says consecutive interior, I'll just put INT, angles. All right, so which ones are the consecutive? This one doesn't make quite as much sense. The book I used to teach out of years and years ago, they called them same side interior angles. To me, that describes it so much better. All right, so let's think about, let's use that phrase. Now, the book uses this phrase, consecutive interior, okay? But I taught out of another book that called them same side interior angles. Let's just use that just to see which ones are same side interior angles. Again, interior angles. So what are my 4 angles that I'm dealing with? 3, 4, 5, and 6. Okay? Now, which ones are on the same side of the transversal and interior? 3 and what? 3 and 5, right. They're on the same side of the transversal. 3 and 5 are interior, and they're both on the left-hand side of that transversal. So those are also considered to be consecutive interior angles. Everybody see that? You see why I like that word same side better? It just describes it a little bit. Consecutive, it could mean a lot of different things. But So let's just list them though. So 3 and 5, would be considered consecutive interior angles. I only got one other pair, and then we're done with this. 4 and 6, that's right. So angle 4 and angle 6 are also considered consecutive interior angles. Everybody got that? It's really important that you know these names because we're going to refer to them a lot. Okay, we're going to do quite a bit with this stuff. $38, is that what I said? Yeah, let's do it. We got time. Now what I'm going to do, what was the name of this lesson? It was something and transversals. Parallel lines and transversals. So guess what I'm going to draw now? 2 parallel lines. That's right. All right, I copied and pasted. Do they look parallel to you? Do I know for a fact, just by looking at this, that they're parallel? I do not know for a fact. How would I know if I looked at a picture? If I just had 2 lines like this, I cannot assume that they're parallel. Well, you don't know. This could be off like half a degree, and eventually, way down the road, they'll cross each other. Okay? But what could I put on here? Oh, I didn't show you this before. Again, I'm thinking of another class. Now watch. In order to say that they are parallel, this is what they do. Now they are lines, so they technically have arrows on the ends. Sometimes I just get too lazy to put them on there. But watch. Sometimes they'll put like an arrow. It's not always thicker, but they'll put it kind of inside there. It doesn't have to be exactly at that spot, but somewhere in there. Do you see those 2 arrows right there? That indicates that what must be true about those 2 lines then? That they're parallel to each other. Everybody got that? So if I have 2 lines and you have an arrow in between here, that means that they are parallel to each other. All right? Now, what am I missing that we've been talking about almost the whole class? Plane? Oh, what? Transversal, right. That was the whole thing. Thought you guys would like just get that right away. I like hand delivered that to you. All right. So let's put the same angles. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now, I'm going to go through this pretty quick. This is what they do. Look at the corresponding angles. So, what's the corresponding angle? Angle 1 and what? 1 and 4? 1 and 4 are not corresponding. What is 1 and 4? What are they? They're vertical angles. What are corresponding? They're the ones that match up. 5, right. This isn't top left. This is top left. So 1 and 5 are corresponding angles. I'm going to tell you right now, we have some theorems. Okay? Just wait a minute. We have a theorem that talks about these angles being equal and other stuff like that. One of our theorems is actually not even a theorem. It's called a postulate. We just accept it without proof. Don't worry about it. It's just the corresponding angles. We have a postulate, a rule, okay, that says that when you have 2 parallel lines cut by transversal. Do we have that situation here? Do I have 2 parallel lines? Yes. Do I have a transversal? Yes. That means if you have that situation, all the corresponding angles are going to be equal to each other. All right? Now we are talking whether they're equal or not equal. Okay? We didn't before. We just named them. So if I said that all the corresponding angles were equal to each other, now I can say what? That angle 1 is equal to what else? Because of corresponding angles. Not all of them. Doesn't equal 3. Okay? Doesn't equal 7. Look, 1's an acute angle, isn't it? 7's obtuse. There's no way an acute and an obtuse would be equal to each other. 1 and 5. That's right. 1 and 5. Okay? Now, we knew before that they were corresponding angles, but now we know if the lines are parallel to each other, now we know the corresponding angles are what? Exact. Not the same. Don't say the same. They are what? Look, I got it right there. Say that word. What is that word? It's equal. Okay, equal or congruent. It's fine. All right? Don't use any other word except for equal or congruent. Don't say they're the same. Is angle 1 the same angle as angle 5? It's not. It's a completely different. Look, this point right here, look, that point is in angle 1. Is that same exact point in angle 5? No. Is angle 1 and angle 5 the same angle? No. But they are what? They're the same degrees. Why are you so against saying this word? They're equal to each other or congruent. Either way, I'm fine with either way. All right? Everybody with me on that? Sorry, I got a little frustrated, but I'm trying to hand deliver this to you, okay? I put corresponding angles are equal, and then you said the same. Say equal. All right, so 1 and 5 are equal. Give me some other things that are equal. Angle 2 and 6 are equal. 3 and 7 are equal. And 4 and 8 are what? Not the same, but equal. Okay? Why are they equal? Because they are what? Corresponding angles. All right? You getting this? All right. Let me do another one. We got to go quicker because times are running out. Alternate, let's do this. We have a theorem that says that the alternate interior angles are equal to each other, and also the alternate, what do you think? Exterior angles are equal to each other. So let's just do this quick. I'm not going to write it down because we don't have time. So, which ones are alternate interior angles? 3 and 6. So what's true about 3 and 6? They are equal. They are equal to each other. What is the problem with not saying equal? I don't understand. Look, we said all these were equal. It should be a logical conclusion, all right, that we're going to use equal here. Because a theorem says it, all right? I could show you why, but I got 2 minutes left, so I can't do it in this amount of time. So 3 and 6 are alternate interior angles. They're equal. What else are alternate interior angles? 4 and 5. They're also what? Equal to each other. What about alternate exterior? 1 and 8. They're equal to each other. 2 and 7 are equal to each other. All right? So those are also equal. You could list them, all right? You could list them if you want. Let me give you one more. The bell's going to ring, but I want you to hang on. I do not want you to leave. Okay, wait until I do this. What's the only one we're missing? We're missing consecutive interior angles. Now, watch very carefully. Don't pack up. Everybody look and pay attention. Which ones are consecutive interior angles? 5 and 3. Now, let me ask you this. Shh. I know you're getting excited, but just bear with me here. So, let's take a look. 3 and 5 are consecutive interior angles. Does it look like they're equal to each other? Why not? Because 3 is what kind of an angle? You said it earlier, Donnell, say it. It's obtuse, and angle 5 is acute. Is there any way an obtuse angle can equal an acute angle? No. So are 3 and 5 equal to each other? No. But they are, I'm going to give you a word. Here we go. It's a word we haven't used before. Supplementary. Supplement, okay, A-R-Y. They're supplementary. What does that mean? It means they add up. Listen to me now. It means they add up to 180 degrees. So 3 and 5 are definitely not equal to each other. That's obtuse, that's acute. There's no way they're equal to each other, but they do add up to be what? 180. Give me another pair of angles that add up to be 180. 4 and 6. 4 and 6. They're consecutive interior angles. 4 and 6. So angle 4 plus what? Angle 6 is also 180 degrees. All right? They're the only ones that are not equal to each other. Everything else, vertical angles are equal, corresponding angles are equal, alternate interior, exterior. These are the ones that are not equal. I'm not going to give you homework tonight, even though it says it on the lesson plans. So no homework tonight. I'm going to do a little bit more tomorrow, then I'll assign the homework tomorrow.